Alright, in this video we're going to look again at logarithmic functions, specifically what kind of transformations we can do to those functions. Alright, and if you'll remember, the parent function for the log base b of x is going to look like this, and then I'm going to have a curve like that, and I'm always going to have that coordinate right there of 1, 0, and that's for any logarithmic function. And again, we're talking about logarithmic functions when b is greater than 1. Okay? Alright, so from this particular point right here, that's where we're going to do all of our transformations from. Okay, similar to the exponential function being at 0, 1, but now we're talking about a logarithmic function. We're going to do it from 1, 0. Alright, so let's take a look at this first one here. First thing I want you to notice is I'm going to change the way that looks a little bit. We know this natural log right here. We know the natural logs is the same thing as saying log base e of x plus 4 minus 2. So when we look at that, if you'll notice the base e here, that is larger than 1. That's 2.718 approximately. So we're going to have a parent function. Let's sketch that real quick. I know it's a logarithmic function, so it's going to go through the point 1, 0, and it's going to look something similar to this. All right? And then now from here, I'm going to look at my minus 2 and plus 4 and make my shifts and transformations from there. All right? The minus 2, again, we're going to start from this point right here. That's where we're making all our shifts from. The minus 2 is going to cause me to go down 2. And then just like before, when I'm inside these parentheses, right, similar to being inside the exponent from the exponentials, I'm going to make this affect me horizontally, and it's going to be opposite of what we think. So this one's going to make me go left 4. So let's go left 4, and I got 1, 2, 3, 4. So here's my new coordinate that's from here. I know I've got a curve similar to this. All right, now my domain and range is going to shift a little bit, right? We still have a range of all real numbers, and my domain is now going to be all numbers, or x is greater than, you can see here I got 1, 2, 3, 4. It's all going to be greater than negative 4. All right, now I have my new asymptote as being at y equals negative 4. All right, so in this one, again, we have a log base 2, so it's going to look just like the parent function, or similar to. I'm going to go through the point 1, 0, and I'm going to have a curve that looks a little bit like this. All right, and so this is the point right here that we're going to shift from. All right, and I'm going to have a similar curve to that. So the first thing I want to notice is I got that minus 1 is inside the parentheses, so it's going to affect me horizontally. And normally I would think it goes left 1, but again, being inside parentheses, it behaves oppositely, so I'm going to go to the right 1. So here's my new point here, and if you'll notice here, I'm not adding or subtracting anything at the end outside of the parentheses, so there's no up or down shift. I can notice this negative right here, and that is going to reflect it across the x-axis. So instead of being a curve that looks like that, it's going to curve down like that because I've just folded it across the x-axis. All right, let's go look at the next one. All right, so in this one, we're going to see a log of 1 minus x plus 2. If you'll notice, we don't have a number right there, right? Normally we've had a number. So here's what you remember is that anytime there's no base on a log, it's automatically assumed to be a log base 10. Okay, so again, whenever you don't have a number with the log, the base is always 10. So since that base is bigger than 1, I'm going to have my normal logarithmic parent function here. I have a point of 1, 0, and I'm going to get my basic curve that looks something like that, and it's from this that I'm going to make all of my reflections and transformations. So the first thing I'm going to do is I'm going to rewrite this function a little bit just so it's a little easier to see. So I've got log, and watch, what I'm going to do here is factor out a negative. So I got x minus 1 now plus 2. And let me show you what I'm talking about. If I take this negative and redistribute it to that x, I get negative x, which I had originally. And then if I take the negative x and distribute it to negative 1, I have a positive 1, which I had originally. So these two expressions are the same thing, just that second one has a negative factored out of it. All right? So now I'm going to look at the plus 2. That's going to go up 2. That minus 1 is going to go right 1. So let's go ahead and make those transformations. Again, I'm shifting from the point 1, 0. So I go up 2, 2, and then right 1. So now I have this spot here, and you're going to have a curve similar to that. However, I have this negative right here that's going to cause it to reflect across the y-axis or horizontally, so it's going to look something like that now. So if I take away that original one, I just redraw that as a reflected across the y-axis or reflected horizontally, and that would be my function. Okay, let's look at one last one right here just to see what would happen here. All right, so again we have a log base 10. Remember, if there is no number there, we know it to be a log base 10. We have no shifting right or left, right? I don't have x minus anything, nor do I have a plus or minus at the end. So I know I'm going to have this parent function here, and it's going to look something like that, all right? Now then, think back to quadratic function, and remember, if I had a 1/2 in front of the x squared, anything that was out in front multiplied to my function that was between 0 and 1 would just compress or squish that shape a little bit. So we're going to be looking at something very similar. We're going to have a curve that's been squished or compressed vertically. Now, if this number were larger than 1, what's going to do is stretch our curve a little bit, okay? So, good thing to remember is all of our normal transformation rules still apply. We're just applying them to a logarithmic function instead of a quadratic or an exponential or anything like that, okay? So use those same basic rules while you're trying to shift and reflect all of our logarithmic functions. Hope this video helps, and we'll see you in the next one.